All right, guys, we're going to start day 2 of Trig. Today we're going to be solving for our angles. The first thing I want to just kind of remind you guys is to please make sure that your calculator is in degree mode. Also, if you have Desmos, make sure, remember you can hit that little wrench up there at the top. Make sure that it's on degrees. You'll be ready to go. Okay, also our trig ratios. We have sine is opposite over hypotenuse, so katoa. Cosine is adjacent over hypotenuse, and tangent is opposite to adjacent. As we did on Wednesday's material, we used our trig ratio, so let's take sine for example, and we put in sine of our angle measure and then our sides, opposite over hypotenuse. Today, we're going to be solving for that angle, and we're going to be using what are called the inverses. So on your calculator, the inverses will appear as sine, -1, cosine, and tangent. We're going to be using those ratios to work backwards, using our sides to find our angles. So if we move over here to the right, it says use the diagram to find all the pieces. Round your answer to the nearest tenth. This means that we can also round our side to the nearest tenth, which saves us a little bit of time. Don't forget that we can use Pythagorean theorem to find our hypotenuse. So 15 squared plus 7 squared is equal to c squared. This is 274 is equal to c squared. And if we go ahead and work that out, square root 274 is rounded to the nearest tenth, 16.6. Now let's get into the new stuff of finding the angle measure. The first thing that it wants us to do is find our angle M. So I'm just going to box M in. And here we have our opposite and our adjacent. This tells me right now that we are going to use our tangent ratio. Yes, I know that this side is 16.6, but unless you absolutely have to, don't use something rounded to then move forward. So we're going to write this out as the tangent of M, because we don't know that degree, is equal to the side opposite over the side adjacent. And just like we did, we're going to have a calculator ready version, and this is where our inverse comes in hand. So we're going to have tangent -1, 15 over 7. And whenever we plug that into the calculator, here's functions, tangent inverse, 15 divided by 7, and we end up with 64.983 ... Now, when we are rounding this, if we are rounding to the nearest tenths, I know that you guys know this is going to round up to 65, but if we write this as just 65, what that tells me is that I've rounded it to the nearest ones place, and that's not actually what we did. So make sure that you attach that 0.0 to the end of it. I'm going to go ahead and move all this work over. So there is for M, and let's work on angle N. So I'm going to go ahead and erase all this. For angle N, I now have 15 as my adjacent and 7 as my opposite. So I'm going to set it up the same way with tangent. The tangent of angle N is equal to the side opposite 7 over the side adjacent 15. And to put it calculator ready, it's going to be the tangent inverse of 7 over 15. And 7 over 15 is going to be 25.0 degrees. Now you will also notice, and this is just kind of another checkpoint, that these two should add up to 90 degrees because our triangle is still going to add up to 180. All right, solve the right triangle. If we are asking to solve the triangle, it wants us to find all the missing pieces. You may or may not have to use trig to find all of those pieces. Case in point, this angle up here at the top. If I just do 90 minus 37, that will give me the measure of angle P. So 90 minus 37 will give me an angle P of 53 degrees. And now we're going to use either of those angles, 53 or 37, it does not matter, to find our side lengths. So I'm just going to go ahead and stick with the 37. In reference to my 37 degree angle R, here is my opposite, hypotenuse, and adjacent. And I'm just going to go ahead and solve for the opposite first. So I'm going to use this opposite and the side that I know, the hypotenuse, which leads me to my sine ratio. So the sine of my 37 degree angle is the opposite over the hypotenuse 22. And if you remember from yesterday, for my calculator ready, I'm going to multiply by 22 to get my answer. It says round to the nearest tenth. So 22 times the sine of 37 gives me a measure for PQ of 13.2. And then let's go ahead and solve for the adjacent. You can use Pythagorean theorem, but again, I would persuade you not to use something rounded like that 13.2 to then go on and find that side adjacent. So if I'm looking at the side adjacent, I now have the adjacent and the hypotenuse. So I'm going to use cosine. Cosine of my 37 degree angle is equal to the adjacent over the hypotenuse, 22. So calculator ready, this is going to be 22 times the cosine of 37. 22 cosine 37 gives me a measure for QR of 17.6. And just a couple more and then we're done. So number 5, we're going to go ahead and subtract. So I have 39 here as my angle measure. Again, it does not matter which one you use to solve for your angles, to solve for your sides, just as long as you set up your proportions correctly. So in this case, I'm going to go ahead and use the 39. I have my adjacent, my hypotenuse, and my opposite. I'm going to go ahead and find the hypotenuse first. So I've got adjacent and hypotenuse, which leads me to cosine. So the cosine of my 39 degree angle is equal to the adjacent 14 over the hypotenuse. And in this case, these two are going to flip-flop. So I'm going to have 14 divided by cosine 39 as my calculator ready. 14 divided by cosine 39 gives me a measure for the hypotenuse of 18.0. And then let's go and find MD. So I'm still going to use the 39. Now I have the opposite and the adjacent, so I'm going to use tangent. Tangent of my 39 degree angle is equal to the opposite O over the adjacent 14. So my calculator ready will be 14 times tangent 39. Which is 11.3 for UMD. And last one. In this case, we do have some angles that we need to find. We can go ahead and use our Pythagorean theorem to solve for UM. So I'm going to set this up. 28 squared minus 19 squared. Let's see, 28 squared. Oh, there we go. 28 squared minus 19 squared is 423. And let's go ahead and do the square root since we don't have to simplify it. So it is 20.6. Okay, now let's work at the angles. If I want to solve for angle E, then I have my adjacent side and my hypotenuse, which leads me to cosine. So the cosine of angle E is going to be the ratio of the adjacent, 19, over the hypotenuse, 28. And to put that calculator ready, I'm going to use the cosine inverse of 19 over 28. So let me get rid of these. 19 divided by 28 gives me 47.3 degrees. Now, if you are confident in that, then you can just subtract to go ahead and get angle U, but I'm going to go ahead and work it out. So if I want to find angle U, I'm going to use, now I've got the opposite and the hypotenuse, so I'm going to use sine. The sine of angle U is equal to the opposite, 19, over the hypotenuse, 28. And calculator ready for that is going to be the sine inverse of 19 over 28. So let's see. Sine inverse 19 over 28 gives me 42.7 degrees. So when we're finding our angles, we're going to set it up the same exact way, but use that inverse button, and you should be good to go.